Hello everybody, how's everybody doing? Hope you're doing fine. Today we're going to have another exciting day. The other day we talked about position, location, place, as Aristotle called it. And today we're going to talk about what appears to be its opposite, infinity, the infinite. When you think about place, location, position, you think about something which is localized. Whereas when you think about infinity, you think about something that's spread out forever, right? Something that never ends. And yeah, the mathematicians use infinity these days, it especially became quite popular among mathematicians at the end of the 19th century. People like Georg Cantor and David Hilbert, they started playing around with infinities. You hear about Hilbert's, Grand Hotel, infinite rooms. Anyways, let's get on with it, with infinity. Where did all this stuff start regarding infinity? It started with the Greeks, at least in the Western world. Several of the Greek so-called philosophers, they began discussing whether there was something that was infinite, whether there was an infinity out there of something, of anything, right? And of course, the primary analyst is Mr. Aristotle. He did analyze infinity in quite a bit of detail, I should say. So I'm going to proceed with him, and I'm not going to look at his his other books, such as Metaphysics. I'm going to look at his physics because I'm interested in what concerns physics. Okay, that's what this channel is about. We only concern with physics, and within that context, does infinity have any validity? Is there any room for infinity? That's the issue, okay? And so we have Mr. Aristotle, and he says the following. He starts by stating what physics is about, essentially what his book is about, what he's going to be addressing. And he says, scientific knowledge, got a problem with that there, in the science of nature. Science of nature, yeah, sounds quite within physics. Physics deals with Mother Nature, as I call it, how the universe works, especially the invisible stuff. The visible part we've figured out. It's the invisible stuff that we have not figured out, all these things that we can't see or touch, the mediator of light, of gravity, of magnetism, etc. That's what we need to figure out. The rest we've figured out, all the visible stuff. Okay, so he's going to do the science of nature. That's essentially what he's going to relate physics to. I've got a problem with the word knowledge first, because knowledge means that you already know. And in science, we do not know. Okay? We do not know what the mediator of light is. We do not know what the mediator of gravity is. We do not know what the mediator of electromagnetism or magnetism or electricity are. We do not know because we can't see all that stuff. We can't touch it. We can touch it indirectly. You can put two magnets together, some iron filings, but you yourself, you cannot touch the mediator. And so all you can do is sit back and try to visualize how Mother Nature could be doing that magic trick. That's the issue. And so we do not know, aside from the fact, because no means that you've already made your decision. You've got an opinion already about something. That's what knowledge means. That means you already know. No one's going to convince you otherwise. And then we find out knowledge is just justified true belief. It's just a belief. And the reality is no one has defined the word knowledge in the last 2,000 plus years since Plato gave his definition. Okay, so knowledge has nothing to do with science, but that's where Aristotle is going to start making some bungling errors. Okay, he's going to go in there and he's going to talk about knowledge in the context of science. And science itself, the word science comes from knowledge. Again, very misleading. Science we explain, we do not know. Okay, so we do not think that we know a thing. okay, until we are acquainted with its primary conditions or first principles. Our first task will be to try to determine what relates to its principles. Okay, what are the principles of physics? Let's see if we can figure that out. Well, in rational science, we have no problem. And here it is, side by side, so you can see it there. What are the principles? Well, we start with, especially physics, right? That's what we're talking about here. Physics requires an object. You can't do physics without an object. That's the golden principle. It's a non-negotiable principle. You can't do physics without an object. If we wiped out all matter from the universe, all objects, what would there be happening? What are you seeing? What's moving? So this is the issue. The issue is the first principle is the golden principle, and Aristotle never figured that out. The next step is that you not only do you have to define what an object is, what something is, but also the other word that's associated with that, and that's existence, exist. We need to know what something and what exist means in order to do physics. You can't do physics without those two words. That's again, these steps are, you cannot avoid them. And Aristotle didn't define either one of these precisely, okay? He had some vague notions of both, but he never defined them scientifically, like I did there, something, colon, followed by a definition. That's how a definition is put forth, okay? He never did that, and that's going to ruin his whole dissertation of physics. His entire dissertation goes down the drain, okay? And we'll see this in what I've got to say today, okay? He's just going to have a little bit of a problem getting his point across of physics, okay? Of physics. Remember, we're doing physics here. We're not doing philosophy. We're not doing what they call philosophy of science, philosophy of physics. No, this is known as physics. Sorry, okay? Philosophy is something else. Okay, so what did Aristotle say regarding what an object is? Because obviously, if you're going to be doing physics, you need an object. And he had some vague notions. These are the notions he's trying to get across to you. And again, he talks a lot about objects in metaphysics. I'm not going to deal with that. I'm going to deal with this book, his book of physics, because that's what this site is about. Metaphysics supposedly is philosophy, is what comes after physics. In other words, when you sit down at the bar and you try to think about what you did in physics, that's metaphysics. Now, this is, I'm interested in what he has to say about physics and what he has to say about what an object is in terms or in the context of physics. Okay, he says substance alone is independent, for everything is predicated of substance as subject. Now, there's an interesting point there. In physics, only substances, things, bodies, objects can serve as the noun, as a subject of a sentence. Anything which is not an object, it cannot be a noun. So the word motion or the word orbit, itinerary, those words are nouns in our regular language, in ordinary speech. They are not nouns for the purposes of physics. You cannot talk about them. You cannot put them as the subject of a sentence. Okay? Orbit is a verb. And itinerary, trajectory, those are all verbs as far as physics is concerned. Okay? So you can talk about Jupiter, but not the orbit of Jupiter. No, it's Jupiter orbits. Okay? That's how it's said in rational science. Okay? So we got a different language. We're redoing the language. Okay? And he says, it is a whole that is best known to sense perception. He's going to introduce the senses. Okay, he's going to think of objects or things as that which you can perceive, that you can sense, that you can touch, etc. And that's a problem, because that's the notion that most people have out there of what an object is, that which you can touch or see. And you'll see that definition quite a bit in dictionaries. No, that definition doesn't cut it in science, in physics. In physics, science, it's that which has shape. And shape is a different criterion than touch or see. But he does say, if bounded by a surface, okay, is the definition of body, absolutely in agreement, right? There cannot be an infinite body, either intelligible or sensible. Okay, now I like a lot of what he's saying there. He's saying, a body, a thing, is that which has shape, which is bounded by a surface. He had the right notion. Okay, he's saying that's what an object is. Okay, and he says if it's bounded by a surface, then it cannot be infinite. Okay, and it was until these bozos of mathematical physics, people like Stephen Hawking, came around. They came out with a finite but unbounded universe. And that can be applied to any object. What he's saying is every object is finite, but you can run around it forever. And he calls that unbounded, meaning infinite. He's trying to get the best of both worlds. He's saying you got a finite, infinite object. It's both. Why? Because it's finite in extent, it's got a surface, but you can run around it infinitely. That's how they're going to use that. That's the unbounded part. Okay, but other than that, Aristotle's got the right idea. He's saying, look, a body is that which is bounded, has a surface, has shape. No problem there. I mean, I think we could see eye to eye on that one. Just maybe tweak a little the language, but he had the right idea. And he says if it's finite, if it's got a surface, well, it can't be infinite. Okay, so he's got the right idea. Unfortunately, he's not going to use this for anything. And that's his other failure. He's not going to use this notion of finiteness, of boundedness. He's not going to use it at all. Why? Because he never defined what an object is, what a thing is, what a substance is, what a body is, precisely. And he keeps going back and forth between body, substance, and then he brings some concepts in there, and he talks about the infinity of concepts. That's where we're going to run into a lot of trouble, because it's those concepts that are going to kill him. If we're going to do physics, let's do physics. Let's talk about objects. That's not what he's going to talk about. Whenever he's going to introduce infinity or infinite or any of those words, well, he's going to apply them to concepts. And yeah, all concepts are quite infinite, because infinite is an adjective that is misapplied when you put them in the context of concepts. Okay. Euclid also, here we have Mr. Euclid, and he also had this notion that a figure, a thing, a body, I guess, substance, all those are synonyms, it's that which is contained by a boundary or boundaries, okay? So he's saying it's that shape. So they had the right idea. Unfortunately, Euclid didn't use this for anything either. Because he's going to introduce, before he introduces this is what, definition 13 and 14. Before he gets there, he gets to point and line, and he's going to treat them as geometric figures. They're still considered as geometric figures to this day. And what shape, what form, what surface does a point have? And they tell you it's zero-dimensional. And you say, well, what kind of shape or what kind of figure is a zero-dimensional whatever? And so what they have to say is that, no. It represents location. And the location can be located with 2, 3, 4 coordinates or whatever. And so they twist it around. They say, if they're going to deal with location, well, location, first of all, is not a geometric figure. And then why use the word point? Just use the word location. But see, the point brings the best of both worlds. It brings the dot, which is a figure, two-dimensional figure, if it's round or square, for example. And it fits into location, which is the concept that they're going to talk about, which is what geometry, or how Euclid's going to use it in geometry, right? And so this is where the problem comes in. They've got their God is both an object and a concept. And they're going to build all their geometric figures with this famous point, zero-dimensional nothing, dot. Okay, so this is where the problem is. And so, yeah, Euclid never used this notion of figure being that which has a boundary, and neither did Aristotle, for that matter. Okay, so what does Aristotle continue with? Well, he says, look, if you're a physicist, you got to deal with the infinite, or the infinite with infinity. You say, huh? Does that word belong to physics? Okay, that's going to be the issue. Okay, does the word infinity have anything to do with physics? He says it is incumbent on the person who specializes in physics to discuss the infinite, okay, and to inquire whether there is such a thing. Well, he never defined thing, and so we've got a problem with the words. Infinite is not a thing. Infinite is a concept, and a concept is way different than a thing. Okay, so he never figured that out, and no one since then has in mathematical physics. Okay, and if there is, what it is, again, infinite is not a what. Like energy is not a what. Mass is not a what. Field is not a what. None of it's an irrational question to ask. What is energy? What is mass? What is a field? Those are irrational questions because it's obvious that they're concepts, and you do not ask in physics, right? In ordinary speech, you can do whatever you want, but in physics, you do not ask, what is love? No, love is not a what. Love is a concept. You can only ask, what is a tree? What is a rock? What is a house? Those you can ask, use the word what. But in physics, we cannot say, what is love? What is energy? What is a wave? No such monsters. Okay, those are concepts. So what is time? You can't ask these questions because they are irrational. So he's got the wrong language because he hasn't said it right. But, we can forgive him because that was 2,000 years ago. What we cannot do is forgive his disciples 2,000 years later who never figured this stuff out. Okay? The physicists regard the infinite as an attribute of a substance, which is different from it and belongs to the class of the so-called elements, water, air, or what is intermediate between them. In other words, the Greeks had this notion of four elements, fifth element with quintessential, the quintessence, right? So again, we can forgive him for this. But he had the right idea. He says the infinite is an attribute of a substance. Okay, and again, in rational physics, you can't have an attribute such as infinity applied to a substance, a thing, a body, an object, as we say. Because all objects, by definition, are those that which have shape, and there is no such thing as an infinite shape. So it's an attribute that we just debunk through the definition of object. There's no such thing as an infinite finite. It's an oxymoron. Okay? But anyways, he says the good part about that is he realizes infinite is an adjective. And you cannot apply an adjective to a verb. You can only apply adjectives to noun to qualify or modify nouns. And the only nouns in physics are those which have shape. So we got to keep the whole thing in the proper perspective. Okay. Okay. Unfortunately, he also introduced a sense in there. The sense of, especially the sense of touch, see and touch. And he says the problem which specially belongs to the physicist is to investigate whether there is a sensible magnitude which is infinite. Well, I don't know how magnitude got involved in this because he was talking about objects and suddenly he switches over to magnitude, which is something related only to math. It has no relation to physics, to the physical world, to the world of objects. And so why he brings up magnitude, who knows? But then he talks about a sensible magnitude, meaning that you can sense it, whatever that can possibly mean. But he does make a point that he is a physicist, okay? Our inquiry as physicists, right, is limited to its special subject matter, the objects of sense. Again, he thinks that an object has something to do with sensing, not by definition that it's that which has shape, but that which you can touch or see, sense. That's where he's going to run into a lot of trouble in his dissertation because he's introducing sense, his senses, okay? And we have to ask whether there is or is not among them a body which is infinite in the direction of increase. Well, I don't know in the direction of increase. There can't be an object that is infinite at all, or a substance or body as he called it. There can't be, because by definition, a body is that which has shape. If he would have defined that from the start, he wouldn't have run into that issue. He could have saved himself half his book, because he discusses a lot on bodies, on infinity, on existence, and he never defines what existence or a body is specifically, and stays with that definition. Because you can define something and say, well, yeah, it's that which has shape, and then you never use it again and start talking about numbers and time and motion. And so why did you define this as a body, as that which has shape, if you're not going to use the definition? And that's more or less where Aristotle is. He's going to go in there and he's going to talk about, magnitudes. What does magnitude have to do with a body having surface or boundary, as he said? So that's where he jumps back and forth between concepts and objects. Okay? And what is the result? Well, here we have an idea. He gives us this notion. Our definition, okay? Let's see what your definition is. Then is as follows. A quantity. A quantity? A quantity is infinite. What does quantity have to do with substance that he was talking about? Okay, and this is where you can see that he just goes off and gives examples that have nothing to do with physics or with what he was talking about, and he jumps back and forth here constantly. And so it's hard to follow him, because whenever he gives an example, he's going to give an example which does not involve a substance, a body. He talks about motion, or he talks about time or magnitude, and so he says a quantity is infinite. I thought we were talking about the infinity of things, okay? If it is such that we can always take a part outside what has been already taken. On the other hand, what has nothing outside it is complete and whole. In other words, if it has something outside of it, it's finite, okay? That's what he's saying, okay? And we define the whole, that from which nothing is wanting, as a whole man or a whole box. Again, he's giving examples of a man and a box, and he's talking about quantity. What does man or box have to do with quantity? And this is where he goes back and forth. His examples don't match what he's talking about at all. And you go through his book completely, and you find all these irreconcilable notions that he puts forth, okay, between what he's talking about and the examples he gives to make his point. It doesn't follow, okay, hardly ever. The whole is that of which nothing is outside, okay? It's complete at that point, right? Nothing's outside of it. On the other hand, that from which something is absent and outside, however small that may be, is not all. It's not complete, right? Whole and complete are either quite identical or closely akin. Nothing is complete which has no end, and the end is a limit. Okay, so again, we don't know if he's talking about an object being finite. If that's what he's going to analyze, he's going to talk about an infinite object, which he already said that there's no object that can be infinite. Okay, and then he talks about magnitudes. And the examples he gives are a man in a box, saying that those are finite. And so you figured it out. What his point was, the point that he was trying to make. And I don't know if you can figure it out with him. Okay, and then he wants to convince you, obviously, as all mathematicians do. They try to convince you that the infinite exists. And he says, to suppose that the infinite does not exist in any way leads obviously to many impossible consequences, okay? There will be a beginning and an end of time. What does time have to do with infinity, with an infinite object, with the adjective infinity if time is not a noun? A magnitude will not be divisible into magnitudes. What does magnitude have to do with physics if magnitude is not a physical object? Number will not be infinite. Number is not a physical object. Number is a verb for the purposes of physics, okay? Science. There is a sense in which the infinite exists. How can the infinite exist if only objects can exist? And of course, if you never define the word exist, then you can say love exists, energy exists. You can say anything exists, even spirits exist. because you never define the word exist. So what is he saying when he says the infinite exists? What does that mean? And another is in which it does not. A thing is infinite either by addition or by division. He's saying that you can add more and more meters to your, I don't know, your roll of cloth, and you add more and more cloth to it, and in that sense you can take, you know, mentally at least, or you can visualize this, of taking that cloth all the way to, you know, kingdom come, to wherever you want, forever. And you can also take a piece of cloth, even 1 meter length piece of cloth, chop it up in pieces, right, and get to the infinity by division. In other words, you can keep chopping it, at least mentally, right, even though not physically, what he calls actuality versus potential. And you can chop up something, at least potentially, mentally, you know, visualize it, and say you can keep chopping up forever. In actuality, you can't do that because at some point your blade is thicker than what you're going to chop, or so to speak. So you can't keep chopping a piece of cloth forever. But you can do it mentally. You can visualize that, or you can talk about that. But what are you talking about? You're talking about math. You're saying you can divide that last piece a gazillionth of a meter or whatever, and you can divide it by 2. And you get half a gazillionth of a meter. Okay, that's all they're saying. So it's only a mathematical trick. What does that have to do with the physical world? That's the question. Does that? Can you extrapolate that to the physical world? Okay, so this is where he's going to run into trouble. Again, his dissertation goes down the drain with all this. A thing is infinite either by addition or by division. And he says there is no difficulty in refuting the theory of indivisible lines. Remember, he's going to use lines to represent, especially the number line, but he's going to use it to talk about motion and time. Okay, and so yeah, you can divide the number line, because that's what it is, a number line, chop it up into little pieces, and that's what you're going to do with motion, that's what you're going to do with time. You can chop it up as much as you want because those are mathematical tricks. They have nothing to do with reality, with the physical world, which is the world of objects, which is the world of the present, in which time plays no role whatsoever. Okay, we're talking about mechanisms here. And so what does he conclude? Well, he says you have to believe. Sounds mathematical. You know, you got to believe. You know, raise your arm and sing and believe. What do you believe in? Believe in the existence of the infinite comes mainly from 5 considerations. Okay, he says, from the nature of time, for it is infinite. Whatever the time being infinite means. From the division of magnitudes, again, you can chop up a magnitude, any number or whatever. Mathematically, you can chop it up, divide it by 2, by 2, by 2, by 2, forever. Okay, that's what he's saying. That from which things come to be is infinite. But I like his 4th one, because the limited always finds its limit in something. Okay, everything is always limited by something different from itself. So can a table be infinite? Well, it cannot be infinite, he says, in a sense, right? Because it bounces against or crashes against or stops against the wall. And so, you know, what stopped the table from continuing? Well, the wall in that case, okay? And there's something that always stops whatever from being infinite, okay? And the only way you can get a true, genuine infinite, listen to this, is if you can go through it without disturbing it in some way. You know, kind of like space, like nothing. You know, you don't disturb nothing with your present. Matter does not disturb space. You know, when you go through space, you do not push, like he said in the case of places, you don't push places around or leave holes behind. No, when you move through space, because space is nothing, that which has no shape, okay, then you're not displacing anything. And in that sense, you can say space is infinite. The only reason you can't is that space is not a physical object, and you cannot apply an adjective to that which is not an object, not in physics. And you cannot apply the adjective infinite to any object, because all objects are by definition that which has shape. Okay, so this is where his dissertation completely fails. Okay, here's where he's going to apply all this. He's going to apply it to motion, and here we have motion in the form of dots. Okay, each one of those dots represents a location. Okay, and of course, if you take that to its logical conclusions, you'll say that it's infinite. You can have infinite motion, like, for example, the universe, all the matter in the universe, you could think that it moves forever, okay? I mean, that's a great possibility, that there's no way to stop any of the matter from moving around. There's no way to convert matter into space, into nothing, having it lose its shape and lose length, width, and height and turn into absolutely nothing, that which does not have shape. So there's no way that you can get rid of matter from the universe. There's no border to cross, no surface, no perimeter that you can step across. So matter cannot leave space, matter cannot turn into space, and therefore matter apparently will be moving forever. Okay? And it probably has been moving forever. I mean, it's more logical to conclude that than to say what the relativists say, that there was a moment of origin of matter. Okay, how about time? Okay, well, here you have time. Time is also moving, you're right? You move just like in motion, except that whereas motion is depicted with dots, with locations, time is depicted with intervals, with lines, okay? Lines between the locations. There's always an interval of time that you can chop up as small as you want between any two locations. And so, yeah, just like motion, time is also infinite, okay, in Aristotle's idea, right, his notion of time. And this comes to the point that he's trying to make, which is he's going to replace, or he's going to simulate this with the line. And the line is that what you see there? It's a two-dimensional bar, right? Elongated rectangle, except that he's going to convert that, or all the Greeks are going to do this. They're going to chop it up into locations also, into those dots, which they call points. And they're not even points. What they're talking about really is the number line, okay? And so they're going to put numbers to each one of those. And some people get confused because they say, what's the number line? No, there's no such thing as a line in mathematics. They have no use for the word line. It's just numbers. But they like to put the word line because it gives them an idea that not only that there's direction, but that that line is infinite. Okay, so everything is infinite in mathematics. Motion, time, and number line. They all extend forever. You can count as much as you want. And again, what is the problem with all this? Well, the problem is that you can't apply the word infinite to concepts, not in physics. Maybe in mathematics, maybe in ordinary speech, maybe in religion, but not in physics. In physics, it's very simple. We have this situation, which I showed the other day, and that's that a number is the verb to count. It's a verb. That's what number means. Number means count. What are you counting? Well, what you're doing is really naming each shake of the hand. So when you do it once, you call it a 1. When you do it 2 times, you call it a 2. If you go a 3rd time, you call it a 3. And so we give names to the number of times that you move your hand. That's essentially what a number is. Okay, it's just the shaking of the hand, and you give names, assign names to each one of those shakes. Okay, depending on how many. Of course, you have 2 shakes comes after 1, 3 shakes comes after 2, and people think that because of that, numbers themselves have direction. And they even think it's got orthogonality, that is perpendicular to, I don't know, to length, width, and height. So, especially when they apply it to time. Okay, so that's what a number is. And because of that, we have, here I'll put this side by side. We have this situation where infinite is an adjective. Adjectives qualify nouns. And number is not a noun. Number is a verb for the purposes of physics, of science, okay? Only in ordinary speech, mathematics, and religion is number a noun. And number means to count, so counting can never be infinite. Counting can at best be incessant. You're talking about incessant counting. That's what infinite numbers means. And when you're saying that the number line is infinite, all you're saying that you can count incessantly, okay? Regarding anything related to physics, well, people usually talk about whether space or the universe is infinite and have this notion that it is. Most people do. And again, it's not the notion that Stephen Hawking had about, finite and unbounded. Finite meaning that it's got a surface, but it's unbounded because you can run around it forever and reach your starting point, that sort of thing, right? No, that's not the notion people have. People say, well, when I look out there in the sky, all I see is darkness beyond the moon, right? All that dark area, and we call that space. And we say, well, I can't see the end of it, so it's got to be infinite. Well, what do they really mean? Do they mean that if you were to run through space, you would never reach the edge of space? Is that what they mean? Well, fortunately, we don't have to take a rocket and start doing that little trick. No, you don't have to do that. All you got to do is sit back and visualize. Can you visualize the shape of space? And if you can, all I need for you to do is to identify the outer, the thing that encompasses, that encapsulates space. What are you going to call that? Thought? Fourth dimension? What are you going to call that? That thing that contains space. We cannot even imagine that which can contain space, because space is that which doesn't have shape. If there were something outside of space, then space would have shape. Okay? Hopefully there's nothing outside of space, meaning, and that's kind of redundant because space is nothing. So yeah, there is only nothing outside of space, meaning space is that which has no shape. And yeah, when you define these terms, then you don't have a problem, because now you can use them consistently. Okay, so here we have the reasoning behind space. Space is not a thing, it's not something, it's not a body, it's not a substance, as mathematical physics believes and spreads. Space is exactly the opposite. Space is nothing, vacuum, emptiness, void. I don't know what other word you can use there, okay? Space, that which doesn't have shape. That's what it is. And if that's what space is, it's the same thing as nothing, vacuum, space, and all those are concepts. Okay, there is no physical object called space, no physical object called vacuum, no physical object called nothing. Those are concepts. Okay, an object is that which has shape. Nothing is that which doesn't. Okay? Concepts are neither finite nor infinite. You cannot say that love is infinite. That's good for poetry, for ordinary speech. You can't say that in physics. Likewise, you can't say infinite energy or infinite mass or infinite whatever. You cannot apply the word infinite to concepts, especially to verbs such as mass and energy. And not only you cannot apply the adjective, but even if they were objects, you cannot say it's an infinite object, because an object is that which has shape, and there is no such thing as an infinite finite. Okay, that's essentially what you're saying. Okay, so what do we have? Well, we have that Mr. Aristotle set the world, especially the mathematical world, on the wrong foot, because he started talking about infinity. And he applied it to concepts, especially to numbers, to magnitudes, as he called them. And so, yeah, that's a serious problem, because when you talk about abstractions, you can talk about infinite angels, infinite spirits. No problem there, because as long as you don't define, or you can, if you got infinite space, you can put infinite angels. It's like, Hilbert's Grand Hotel. You can put as many people as you want, because all you have to do is state that it's infinite, whatever that means. Does that mean you count forever? Is that what it means? Well, that's okay in mathematics. In physics, we have to look at it from an object's point of view. You got to say, can you visualize the object? Can you visualize the shape of the object? And then it has to be, if you can, it's an object. If not, then it's not an infinite object. It's not an object. That's what it is. It's not an object. And so good old Airy, he set the mathematical world on the wrong foot. A lot of people took their cues from him and essentially developed mathematical physics using that as a foundation. They changed a lot of notions, obviously, over time. But today we have the word infinity still in there. And if it stays in math, no problem. The problem is that these people like Georg Cantor and David Hilbert and others, they started bringing this word infinite, into physics. And they started to talking about two possibilities. One, infinite objects, infinite atoms, right? And one possibility there is that atoms are created constantly from the void or from energy or from mathematics or from who knows what. And so if you create new objects every day, well then, yeah, you're going to have an infinite spring there, an infinite gushing spring, just throwing particles constantly into the universe. And yeah, you're going to count forever if God just puts particles out of his magic wand, okay? That's one notion. The other notion is an object that is infinite, and for that they have to turn space into an object, and then they tell you that's infinite. And what do they mean by that? Well, they mean that, again, what the notion that Stephen Hawking has, that it's finite, it's an expanding balloon, meaning that obviously there must be something on the outside of it, but it's an unscientific question because we have no way of proving it, as they say. Now, this is a conceptual issue. We don't go to the edge of space to find out if there's something outside of it. It's a conceptual issue. Does space have shape? And if it does, what is it? A balloon? Is it a three-dimensional balloon expanding against what? The fourth dimension? Against thought? Against what's outside of space? And if you can't tell me that, then you can't even use that. You can't say it's unscientific. No, you're unscientific. That's the way it works in science. And if space is finite, then space is a thing. Okay? And if it's a thing, you can't say, well, but I can run around it forever. No, that's not infinity, that's incessant running, not infinite space. Okay, so we got to keep the language straight so that we can communicate. And so with that, I'll see you next time around. We'll see you then. Bye.